Coming, everyone. My name is Matt. I work at Square, and I work on the cache team. So today I'm going to be talking about stealing the web's best feature. Now, if you're expecting to find out what the web's best feature is right now and then take off for the day, sorry, you're going to have to wait at least half an hour before I answer that question. Instead, I'm going to spend a whole bunch of time talking about business logic. So this is a term you've probably heard a lot. This is the logic in your app that's related to the business side of things and not the architecture. These are the things that your product and your design team determine. So some examples of this are, what is a valid username? 40 to 20 characters, for example, alphanumeric with support for underscores and dashes. Another example, is your password secure enough? So 8 minimum characters, at least 1 lowercase, at least 1 uppercase, 1 number, 1 special character. We all know the drill for this. When do you nag for a rating? This is something that you've probably been forced to implement in your app. After some amount of time, you nag your users, please rate our app 5 stars. When do you do this? Do you do it after a week of using the app? Do something a little more sophisticated and wait until 3 successful payments where you think your users are happy with the app. What is the maximum length of a tweet? Well, obviously the answer is 140 characters, except that they just changed that, and now it's 140-ish because there's a whole bunch of things that don't contribute to the tweet length count anymore. How do you render your data? So this is UI related. Given your data, you need to map it to something on the screen. So is the status text going to be green? Is it going to be red? Is it going to be gray? You need to pick an appropriate icon to show. You generally will take an enum and map it to a string. How does your referral program work? Something else that a lot of people are probably familiar with, trying to grow your product. Do you pay out $1 per successful referral? Do you pay out $10 after referring 5 people? All of these are business logic, and they're to varying degrees of complexity. Now, the question I ask is, where should this logic live? Well, there's 2 parties involved, so your options are fairly limited here. However, you have to keep in mind that the client is typically multiple different platforms. In our case, we have Android, we have iOS, and we have the web. So let's take a look at sticking the business logic on the client. So for this, you bake the logic into your APK, and the logic is fixed for a given app version. So for my example before of username validation, the client is hard-coded to check whether the username is greater or equal to 4 characters, less than or equal to 20 characters. So let's look at the pros and cons of this approach. You get a fast feedback loop. The logic is executed locally on the client. So you're able to, while typing, update the status of buttons on the screen or change the color of text to show that it's valid or not. Downside to this is that it requires an app update to change your logic. And generally, your users don't update right away. If you haven't checked your version distribution of your app, I encourage you to go check it and be amazed at how many of your users are using app versions that you released a year ago. Your code is duplicated across all your platforms. So for us, we have Android, iOS, and web. All of those would be re-implementing the exact same business logic. And when they all implement it themselves, then there's potential mismatch between all the platforms. And when you implement something 3 times, there's 3 times the chance of bugs getting introduced. All right, so let's take a look at what happens when you put the business logic on the server. So in this approach, the client does not care about the data. It just sends it to the server and lets the server handle it. Typically, the server will return an error message and a status so the client can show it, but the client doesn't do anything beyond that. So with this approach, the logic can be updated independent of app updates. Your server does a deploy, and now there's new business logic that your client is receiving. All of your platforms are in sync because they didn't write any code. Downside to this is that you have a slow feedback loop. So every time you want to validate something or run this business logic, you have to do a round trip to the server. Client must be online for this to happen. And depending on your use case, this is going to be harder for the client to implement because you're adding new round trips for things that were previously just done on the client. All right, so what happens if we split this logic between the client and the server? So what I mean by this is that the client will bake in a variable logic, and the values for this are provided by the server. So for our username example, the client bakes in its logic where it knows that there's a minimum length and it knows that there's a maximum length, and it checks that the username fits within that range, but the exact values are provided by the server through a config. Another example of this are feature or experiment flags. So your client will implement 2 or 3 completely different logics, and then the server just sends down a flag of which one to execute. So how does this compare? Once again, you have a fast feedback loop because all of your logic is being executed on the client. Your logic can be updated independent of app updates, and all your platforms are in sync. However, there's asterisks on there because this is only true if you don't add new variables to the equation. So in our username example, I've been talking about minimum and maximum length of username, and that's what the client is programmed or knows how to check. However, if you wanted to add a new rule where you have valid characters, then now you still need to push out another app update so it knows to check these new values being provided by the server. And when you add these new rules, then you can once again fall out of sync across all your platforms, and you're duplicating code again. So this is medium to hard client complexity because there's just so much code involved in this. All right, so in summary, if your business logic lives on the client, then your PM is sad because changing the logic is expensive and slow. Your PM comes to you and says, hey, we want to change this username. We want to allow 25 characters instead of 20. And then you need to make that change. Well, all of your platforms need to make that change. They all need to get deployed at their own schedule. You're not going to push out an update the next day just to make this change. And then all of your users need to update, which, as I said, it can take up to a year until you get rid of the long tail of users. If the logic lives on your server, then your users are sad, because now your app is really slow. It's always talking to the server to be able to perform things that should be really quick. And if you split it up, then you, the developer, are sad because you're writing a stupid amount of code. Let's take a quick minute and talk about hybrid apps. And these are basically just really advanced web views. So the server sends down HTML, CSS, and JavaScript that tries to look and behave like a native app. So some example frameworks for this are PhoneGap and Cordova. So if you are the sole developer that has been tasked with creating the Android app, the iOS app, and the server for your company's new smart Bluetooth and Wi-Fi enabled kitchen appliance, and you have 3 months to do it, then this is probably an appropriate solution for you. However, if that's not the case, then generally native apps are much better. For a variety of reasons. The limited number of these hybrid apps that I've used on my phone, I did not enjoy. They were very slow and very crappy. However, this isn't completely wrong. I didn't put this up there just to crap all over it. Let's take a closer look at what these are. So as I said, it's HTML and CSS to run the UI of your app, and you have JavaScript, which runs the logic. And then there's extra Android bits so that your app can integrate with things like Bluetooth. So the parts that I'm saying are really crappy are the UI parts, the HTML and the CSS. So we've decided that we want to implement a native app, so we're not going to use HTML and CSS. And because we're doing a native app, we also don't need these Android bits. So that leaves us with JavaScript. And some of you might not like JavaScript. However, the awful part of JavaScript is generally the stuff that deals with the DOM. And because we don't have HTML, then we don't have a DOM. And when you get rid of all of that, then JavaScript is a perfectly fine scripting language. So let's look at who can run JavaScript. We got the web, which obviously is able to run JavaScript. You have iOS, which is actually able to run it without any sort of modifications. It has a native JavaScript interpolator or evaluator engine. You have your server, which probably can run JavaScript depending on what language it's written in. Our server is written in Java. There's libraries you can pull in that let it execute JavaScript. And now, how about Android? Well, this wouldn't be a good talk if I was just about to tell you, no, you can't run JavaScript. So, see you all later. Yes, it can. We have this library called Duct Tape Android. So what Duct Tape is, it is a compact, embeddable JavaScript engine written in C. We have nothing to do with that. What we have is duct tape Android, which is duct tape packaged to run on Android with JNI bindings. And I believe as of yesterday, this was updated to version 1.0, so API should be stable and ready to use. All right, so let's start with a simple example. Back to our username validation. So here is a very simple JavaScript function which validates the username based on its length. Just checks that it's within 420 characters. Here's a slightly better one that when the username is invalid, it returns an appropriate error message and returns null when it is valid. So in your Java, you just create a new duct tape instance, and then you call evaluate. And the first variable you pass in, this is your script. It is the function that I showed you earlier as a string. And then the second parameter is an optional name that is used for stack traces. So if your JavaScript throws an exception, duct tape Android will synthesize the stack trace to go through the JavaScript that you provided. All right, so we can call this function by calling evaluate again, and we are passing in a string, which is the method call in JavaScript. So this is pretty gross. You're basically crafting a JavaScript string. You have this gross escaping. Username in this example probably can't have a quote in it. It'll crash. The return type of evaluate is an object. So we are casting it to a string, which could lead to runtime exceptions. So we can make this better. So this is an interface that we'd like to use. It's a validator. It has one method called validate username, takes in the username, and returns the string, which is the potential error message. Here's a bit of JavaScript that we can add. It is a global JavaScript object called validator, and it has one method inside of it called validate username, and that matches the signature of the Java interface that we provide above. So this is what our gross code looked like before. So we can get duct tape to create an instance of this validator for us, which will bind it to the JavaScript object that we defined earlier. So the first parameter is the string. This is the JavaScript object. And the second parameter is our interface that it's going to implement for us. And then we take this code, and then we replace it with a simple call to the validate username method. So this looks a lot better. It's type safe. It's just a lot cleaner to look at. All right, so let's go in the other direction. Let's call our Java from our JavaScript. Why would you do this? So one very great example is for logging. So you want, the JavaScript right now is basically this black box for you. You call into it, it returns you something. And ideally, you're able to look at the logs that it's spitting out. So we can create an interface. We'll call it JS Logger. And just for simplicity of this talk, it's going to have one method called D, which is for logging a debug message. We create a new instance of this JS Logger. And in our implementation of D, we are just going to proxy that to Timber. And then instead of get, we are going to call it duct tape set. First parameter is the JavaScript object that we want duct tape to create for us. The second is our Java interface. And the third is the implementation of that interface that we just provided above. Then our JavaScript can just call jslogger.d, and this will call back up to Java for us and proxy it through Timber, and then we'll get all this in our logcat outputs, or whatever other trees you've planted into Timber. So let's get to a little more complicated example. Let's talk about date formatting. So maybe your JavaScript is running some UI portions of your app, and you want to render dates in a human-readable string. Now, as Android developers, you're aware that your users like to customize everything, and there is a setting on your phone to specify 12-hour or 24-hour clock. And also, your phone will adjust the way that it displays dates depending on where you are or what language you're using, I think. So your JavaScript doesn't know anything about this, but we can tell it about that. So just like before, we're going to define an interface. We'll call it date formatter. it has one method called format, takes in a time, and returns a string. We create a new implementation of this where it simply calls this fantastic dateUtils method, format datetime, which will render the date according to the user's preferences. And then just like before, we call duct tape set, use date formatter, and then in our JavaScript, we can just call dateFormatter.format, pass in a date, and this will render the date in human-readable string according to the user's preferences. Let's get even crazier. Let's let our JavaScript read and write data to persistent storage. So just like before, we have an interface called storage. It's got a write method that lets you set data, and a read method, which will let you read the string out. I'm not going to go into the implementation. It's basically just the slides from before, but you can read and write from shared preferences, or if you want, you can have it talk to a database. You get the idea. So let's look at our pipeline and cache and how we set up our JavaScript. So we've got our client and our server, and inside our APK, we actually ship a copy of the JavaScript. This is a snapshot of what it looked like when we built that APK. So we always have that available to us. This is a lie. We didn't really copy it out of the APK. It just looks nicer down there. Now, our server also has a copy of JavaScript, and this is one that's going to be updated with new server deploys. And what we do here is we download the JavaScript from the server, save it to disk, and now we use that one instead of the one that shipped with our APK. So our JavaScript is actually unit tested on the server, allows us to make sure it's reliable, and this code is not too complicated to keep your JavaScript in sync with the server. However, it's code that you currently have to write, which we don't want you to have to write. So eventually, we're planning to roll this kind of pipeline into duct tape Android. So we'll do all the work for you and make sure your scripts are up to date. So I said that we ship JavaScript in our APK. We have a very simple download task or a Gradle task that grabs the JavaScript from the server, saves it into our repo, and we actually check this in. This isn't something that's done at build time because we want stable builds. If we go and we check out an old build, we want the JavaScript that was shipped at that build. All right, so how does this compare to our previous solutions? Well, once again, we have a fast feedback loop. All of this logic is executed on the client. The logic can be updated independent of our app updates. Just download new JavaScript. All of our platforms are in sync because they're not writing this logic. However, it's medium client complexity for the first JavaScript integration you write because you have to write this whole pipeline. However, once you've done it once, adding new methods is really easy. It's just a few lines of code. All right, so let's talk about why we went down this path in the first place. We didn't do all this work just so we could validate a username and then change that logic without updating the app. That's way too much work for that. So let's talk about Square Cash's activity. So this is a list of all of the payments that you've made in the app. So we have to sync these with the server. So let's look at the first version of activity syncing that shipped many years ago. So the client calls the server, says, give me my payments. And the server says, all right, here's your payments. Done. Then 5 minutes later, the client calls the server again, give me my payments. And the server says, all right, here's all of your payments again. So this is obviously inefficient. We basically just wrote this to get it out the door and move on to more important things. So the reason this is inefficient is that 3 months from now or a year from now, this is what your response looks like. You've accumulated a lot more payments. So this is a lot of bandwidth to be occupying every time you want to get payments, which we do quite frequently. And it's also a high load on the server to have to continuously pull these payments from the database and ship them over to you. So let's talk about version 2. The first part of this protocol is exactly the same. We call the server, say, give me my payments. The server says, all right, here's all your payments. However, this time, the server also provides a sync token, in this case, sync token A. So 5 minutes later, we call the server again. We say, get me my payments, and here's the last sync token that you gave me. And the server responds with, nothing's changed. You're up to date. And then a few hours later, we call the server again, give me my payments, here's my last sync token. And the server says, oh, okay, so 3 payments have been updated since the last time you synced. Here's those payments, and here's a new sync token. So this seems easy enough. However, enter problem 1. These are a bunch of screens in the app that render payments. And on the cache team, for whatever reason, we just love server-driven data and server-driven just everything. So that text, that comes from the server. That description, that's also from the server. That title's from the server. That text is from the server. That little status message there, that's also from the server. That button and that button, those are ours. We ship those. I put a lot of work into writing those strings. However, that's server. That icon is server. That status is the server. That label's the server. That message is the server. That label's the server. That message is also the server. So there's a problem here, in that whenever the server or our product team wants to change one of these strings, we have to resync all of the payments that are currently rendering these strings. And as I said, these change very frequently. We have compliance reasons, and also just our design loves to iterate a lot on how things look. So these change all the time. So we would constantly have to be resyncing all of your payments, which completely nullifies all the work we put into this very fancy syncing model. All right, so how can we solve this? Well, one thing we can do is we can take out all the strings from the payments. So we keep our old get payments syncing model. And we also have a new one for getting the strings. And then the payments reference strings in our strings map using IDs. That's kind of gross, but it works. Except that in our case, it doesn't work. So here's a payment, and this payment has a status message. Your cash has been sent to your bank account. It will be available by tomorrow. The key thing to note here is that it says by tomorrow. So in 24 hours, that string is going to change. How does this work? The server is going to have to somehow invalidate that payment in 24 hours so that the client resyncs it. And from the server's perspective, nothing about that payment has changed. When we pay out money, we tell the bank, deposit this money to this bank account, and the bank says, all right, cool. It'll be done in, we don't know when, some 2 days maybe. And the server's like, all right, cool, payment's paid out. We're not looking at this payment ever again. So we'd have to implement something on the server which knows that these payments need to resync in 24 hours. And this is gross. So how would we do this instead? So we keep our get payments. We also keep our get strings. And then in our payment object, instead of providing a description, we provide a map of descriptions where the key is a time that a string would take effect. This is gross. Don't do this. This is kind of when we took a step back and said, no, this is wrong. Let's do something else. This doesn't scale. If we want to do this across 5 different strings in the payment, it's just ridiculous. So here's how we did it. We kept our payment syncing model with the sync tokens. Then we take our payments, and then we save them to the database. And then whenever we want to render our payments, we proxy them through our JavaScript before they get to our rendering code. So this solves all of our problems. Our strings are specified in the JavaScript, so that can be changed. Oh yeah, as I said before, our server can swap out this JavaScript at any time. So our strings are in the JavaScript, which gets changed, and JavaScript is able to tell the time. So if you send a payment through the JavaScript and it says it's going to pay it by tomorrow, if you send that exact same payment through the JavaScript, 24 hours later, it's going to say, this is paid out to your bank account. Now, the interesting thing here is, what do we pass to the JavaScript? We could establish some contract that says, given a payment, pass in these 5 fields from the payment into the JavaScript so that we can give you your render data. However, if the server ever decides that it needs information that's not part of the original contract, then once again, we need to update the client. So instead, in our payment, we have this field, JS data, which is just a blob of JSON text that we don't care about. We just store it for the sole purpose of passing it into the JavaScript. So if the server wants new information that wasn't provided previously, then it can add it to this JS data blob and then resync all the payments in this rare case that new data is needed, and then that will get sent down to the JavaScript, and the JavaScript knows how to handle that. So this is fantastic. Whenever we update our business logic, all we need to do is update the JavaScript. Don't have to resync all of our payments, and all of the client versions, since we implemented this, received this update of business logic. All right, so some pro tips for duct tape Android. Duct tape is mutable, so be very careful if you're sharing it between threads, or better yet, don't share it between threads. We have a dedicated looper that we run all our duct tape code on, so it can't be run concurrently, and it's in the background. Also, you can't use any of the new fancy ES6 features of JavaScript, 6.5 and 5.1. All right, so what is the web's best feature? Is it JavaScript? No, absolutely not. The web's best feature, from my perspective, is that when you make a change and you deploy that change, everybody who's using your product on the web receives that change. There's no long tail of users using an old version of your website that you have to support on the server. And with JavaScript and duct tape Android in particular, you can do this. When you deploy a change to your business logic through JavaScript, and everybody receives this instantly. So this isn't a solution for everybody. This is something that we needed to do, something that you might consider doing. I encourage you that when you're making decisions about where your business logic lives, to keep this in mind. All right, thank you.